Hey guys, and welcome to my channel. For this video I'm going to show you how to rewire an electric garage heater to use an external 24 volt smart thermostat. So I have here a 75 watts electric garage heater by Profusion, as you can see. Model number EH4604B that I installed about 5 years ago. As you can see, I have it mounted to the ceiling in my garage, which is about 11 feet off the ground, and every time I need to use it, I have to get on a ladder just to turn it on and off. So I thought maybe it's about time to update it and make it more accessible. So for this project, I'm going to modify it and use a smart thermostat so that I can control it from ground level or control it from my phone. So I'm going to take it down and show you what the wiring looks like inside. So here's the wiring inside our electric heater. So you got your Romex 8 gauge wire coming in here. You got 240 volts, which is then connected to L1, L2 of this terminal. You got your contactor. This is your temperature control thermostat. And then you got your switch, and then this is your limit switch. This particular heater comes with this temperature control thermostat, which has a two connection. One on the left side is connected to L1 of this terminal, and then the other side you got a piggyback connector. One goes to our contactor and the other one goes to our fan motor. Okay. Basically, the way this works is that when you have this control knob all the way to the left, basically that's off, and when you turn it clockwise or to the right, you're going to hear a clicking sound right there. So basically that tells you that you made contact or connection between these two terminals. There's two terminals inside this thermostat, so which basically allows electricity to flow from here to this side, and then that power or electricity goes to our contactor, which then turns on or closes this contactor, and then which then sends power to our heating elements. You got one right there and then the other one right there, and then it also sends electricity to our fan motor. Okay, now this also has this limit switch. Okay, it basically controls the fan on and off. This control also provides a safety limit that turns off the heating element if the temperature of the heater gets too high or too hot. So I'm not going to mess with that. We're just going to leave that alone. On the other side of this terminal, you got L2 right here is connected to our limit switch. Okay, and then on the other side of this limit switch is connected to, I think it's right here, that goes to our contactor. This one has another piggyback connector, and then that one on the other side of this, the other connector goes to our fan motor. So basically that completes the electrical circuit. So now this heater also gave you an option for an external thermostat. However, This would be a high voltage thermostat, so you have 240 volts. So you'll need a 240 volt thermostat. And if you just want to add a 240 volt thermostat, then you'll need to use this other terminal. This is basically where you'll be connecting the thermostat directly, and then that you'll be done. So, but for this project, I want to use a smart thermostat, which uses low voltage, which draws 24 volts of electricity, and in order for us to achieve that, we'll need to use a transformer, specifically a step-down transformer. And the purpose of that step-down transformer is to convert high voltage electricity, and in our case we have 240 volts down to 24 volts. So let me show you now what we'll need for this project and how we're going to rewire this heater. So everything here that I'm going to show you, you can purchase online or from Amazon, and I've also listed them in the description below with links. So first, you will need a transformer. This one in particular is a step-down transformer. It's a mini transformer. So you got these wires: red, green, black, white. These will be for your high voltage connection, and then the red and green on the other side, these are your low voltage wire connection. So this transformer, you can actually use this for 120 volt, 208 volt, and then 240 volts. If you're going to use 120, you will need white and black. And then for 208 volts, you would need white and red. And then for the 240 volts, in our case, we're going to be using white and orange. And then the red and black, since we're not going to use these, we're just going to cap them. Okay, we're going to put caps on these. This particular transformer is made by Packard, model number PF42440, right there. Okay, next thing we'll need is a power relay to turn the contactor on and off. So this is what I got. Now this one is by Zettler. It's a mini power relay, part number AZ2280-1C-24AF. Okay, and 24, I think, is for 24 volts, I believe. So, and then finally for the fan, I decided to add a fan timer right here, which has a built-in delay on make and delay on break. Now this delay on make, the delay on make on this is 1 second, and the delay on break is 60 seconds right here. This one is by ICM Controls, part number ICM255. So like I said, all of these will be in the description below with links. Now let me show you how we're going to rewire this heater. Here's a wiring diagram that I drew. Here's the contactor, here's the relay, the step-down transformer, and here's the fan control board or fan timer. Let's start at the power source. So you have 240 volts of electricity coming in using a number 8 gauge Romex wire, which is connected to the L1 and L2 of the heater terminal as shown here. And the ground wire is connected to the green ground screw in the heater. So our contactor is a 240 volt contactor,
And in order for us to turn it on, we need a high voltage relay to turn the contactor on and off. A relay here, we have 3 high voltage terminals located here. I've labeled them as supply, normally closed or NC, and normally open or NO. The NO and NC refer to the communication of these terminals with the supply voltage. And high voltage is supplied to this terminal as shown in this black wire. We have a wire going from L1 to the supply terminal. So you can see the contactor is connected to NO terminal of the relay with this black wire. NO refers to as there being no continuity when in normal position. Basically, the circuit is open, meaning no current is flowing through it. And now here we have the white wire from the thermostat, which is connected to one of the low voltage terminals in the relay. Now, depending on what type of thermostat you decided to use, when you set your thermostat higher than the current indoor temperature in order to request heat, the thermostat tells the relay that we want to turn the heater on. When that happens, the coil in the relay is energized, which activates the NO terminal, and the circuit closes, allowing high voltage current to flow from supply terminal to the contactor. Now the contactor turns on the heating elements and the fan motor. Also, there's a piggyback wire here that connects the supply terminal of relay and the NO terminal of the fan control board. And then a wire is connected from the supply terminal of the fan control board to the fan motor, and from the fan motor to the contactor, completing the high voltage circuit. Now let's take a look at the fan control board. Now this control board has a built-in relay, which would control the high voltage supply to the fan motor. Now this built-in relay would have the same principle as the relay that controls the contactor. Now the control board has 3 terminals for low voltage, R, C, and G, as you can see. The R terminal is connected to the 24 volts red wire from the transformer. This R terminal needs constant supply of 24 volts at all times. Now the C terminal is connected to the transformer's green wire, which is a low voltage common wire. And finally, the G terminal is connected to the thermostat's white wire, as shown here. So when you apply 24 volts coming from the thermostat to the G terminal, the NO terminal here will now have continuity with the supply voltage, allowing high voltage current to flow from the supply terminal to the fan motor by this black wire. Turning the fan motor on. Like I said earlier, this fan control board has a built-in delay on make and a delay on break. The way this works, when the thermostat is turned on, the first thing that will happen is that the contactor will close, the heating elements will warm up, and since this board has a delay on make set to 1 second, the fan will turn on after 1 second the coils start to warm up. Now the delay on break works is that when you turn the thermostat off, the contactor will open and the heating elements will shut down, but the fan blower control unit will keep the fan running for 60 seconds to cool the heating elements and get all the heat out of the coils. Now let's take a look at the transformer and how the wires are connected. This is a 24 volts transformer, since we have 240 volts coming in, and we have 24 volts going down to the thermostat. Now this particular transformer has 3 different high voltages that you can convert to 24 volts. We have 120, 208, and 240 volts. In our case, since we have 240 volts coming in, we are going to use the white wire and the orange wire, which are connected to L1 and L2 of the terminals as shown. The other two wires, red and black, since we are not going to use them, you need to put caps on them, so end caps. Now on the other side of the transformer, you have low voltage wires, red and green. The green wire is connected to the common terminal of the relay, the fan control board, and the thermostat as shown here. And the red wire is connected to the red terminal of the fan control board and the R terminal of the thermostat as shown here, basically to deliver power. So this is how we're going to rewire a heater. One important thing, in case of electrical short and to protect our transformer, I've decided to add an inline fuse shown here. I'll be using a 2 amp fuse in the red wire of the low voltage wire of the transformer. Now this is very important, so don't forget to add this. Also, to have a good electrical path and to make it look clean, I'll be using a fuse holder for this project. And that's it. And one important note, for safety, please make sure that all end connections are tight and secure. Make sure to double check or triple check your wiring and use electrical tape to secure the end cap connectors. And finally, make sure that you shut off the breaker in the main electrical panel. So here's the completed installed garage heater with the high voltage and low voltage wires completed. Here we have the 3 wire nuts for the low voltage wires. And here's the 2 amp fuse in the red low voltage wire of the transformer.
Okay guys, finished with the wiring, and I turned the power back on, as you can see. And also I just finished setting up my Nest smart thermostat. So we're going to test it out now. Okay. You heard the contactor closing, and the fan is on. I can feel the heat. It's warm heat. So now I'm going to turn the temperature down and turn up the heater. Okay, that was the contactor again opening up, but then the fan is still on. That's going to continue running for about 60 seconds or a minute. So we'll see. There it goes. Alright guys, hope you enjoyed this video. Guys, thanks for watching. Don't forget to like, share, and subscribe. Thank you. Bye.